mathematics. There are two aspects. On one side, we need to teach mathematics so that students learn how to solve problems, mathematical problems, and the other aspect to it is to develop analytical thinking among students. Very often this second aspect is missing in the way that people teach mathematics, because very often I meet students who have learned mathematics mainly through memorization, not through understanding. While learning mathematics through understanding will develop analytical thinking skills, which is very important not only in mathematics but in life, in any career. So I think the second aspect of learning mathematics is more important than the first one, because if you don't have the second one, the first one will be difficult really to gain, because solving problems without analytical thinking capabilities. What are the few things that contribute to this, to developing of a methodology that will help students to learn mathematics in a better way and for lifelong lasting knowledge? Diversity of courses taught. If the professor has taught many different courses, then gets this exposure to different courses and different ways of explaining. Diversity of student population. One thing that I enjoy every day in teaching, being a teacher in Manhattan, which is, I think, world's most, maybe not the most one, but it's very diverse. I had classes where not two students were from the same country. All students were from different countries. Different backgrounds, different races. So it is very interesting to teach in such a class. It's also very challenging because they have studied mathematics in different ways, and I had students, for example, it was my favorite example, from Bangladesh. He was all the time trying to find the philosophy in it. The American students were trying to just understand what are the steps to do to memorize. And these guys kind of all the time, what is the philosophy, professor? Okay. Which was really interesting, and it's also challenging also. Another one is there is still teaching modalities. Our college is a very flexible college, and we have like group studies. I have done classrooms. Group studies are more like discussional kind of classes, and one-on-one, on distance, blended, online. So all this makes a teacher more grounded maybe in teaching skills, which also helps with finding methods of teaching more effectively. And of course, good knowledge of subject matter. This is something that very often concerns me when my students come and say, Professor, I need 8 credits in mathematics so that I can become an elementary school teacher. And 8 credits of intro mathematics to teach kids, it's enough maybe, but it's not really something that I don't think this serves well to students and when they become teachers. So good knowledge of subject matter is very important. Okay, so my PhD is not in mathematical education. My PhD is in mathematical logic, and that's why I like to observe students' thinking processes. So I'm not like a regular research doing math education person, but my is mostly observations. And I teach mathematics and I teach computer courses also. And my favorite example in this is I was teaching internet marketing, and a couple of times I was not happy with my teaching. and students were just happy for the class. How it can happen, because the topic was interesting. And if I do excellent class, sometimes students can feel not that comfortable. So it's very important if students are engaged in the class or not. Do they like the subject or not? Do they want to be in my class or not? Really not. Because in New York State, for a degree, all students have to have credits in mathematics. So they have to do mathematics. Another observation is that as we talked about that my Bangladeshi student was searching philosophy, and then, so it very much depends on the ethnic background and how students approach the problem solving. What is how they feel about the class in general. And also age. Also, our college is for adults, and the average age is, I think, around 40s in our business. So I have many students that were much older than I am, which is really interesting to teach. So we have this diversity, and I can see the differences of thinking processes and learning of different ages. And of course, it very much depends if the student is studying one-on-one or the student is in the classroom. So their learning and comprehension is very different depending on the way student of the teaching modality. And we talked about a good knowledge of the topic, in my case of mathematics, because if students cannot understand in the way I explain, I can always explain it in another way, or from the questions that students ask, I immediately spot the gap in the knowledge and just like quickly cover that part, and then students understand. So good knowledge is very important. What are the sources? As I said, my PhD is in mathematical logic, so mathematical logic really helps me in teaching mathematics, even any level of mathematics. Historical roots of teaching mathematics, and because there's a lot of stuff to learn from the history. Observation of reasoning processes, it's also interesting. It's very helpful because I can see how students think, and that helps me to come up with better ways of explaining stuff. And of course, research on math education is something that is valuable also. So how to nurture analytical thinking and problem-solving skills using mathematical knowledge, and all the four that I talked about. I'm not going to stop on this a lot. I'm going to publish an article where I go over what we can get from mathematical logic in teaching methodology. I do research, and I have published my book on Analytical, who is an Armenian mathematician of the 7th century, and his book, his textbook of arithmetic, is the oldest survived textbook, and I have published a book on it, and I learned a lot from his methodology of teaching, and I wish I could teach really in elementary school, and I feel my students could be really great, because the way it's being taught in the US in elementary school, it can be done much better way. And Anna Shiraka's methodology is really interesting one. This is my book, and it's a available in Amazon. Observation of reasoning processes. The two most important weak loops in student learning are variables and parentheses. It's very interesting. Variable is something that maybe because in US people are very really they seek application in everything. Maybe that is why abstract thinking. Maybe it's another thing that it should be developed in abstract thinking. It's mainly I think that I haven't done much research on that, but that's my thinking that abstract thinking skills are very important to make students to understand what is variable, because variable is really something abstract. It doesn't have a concrete value in it. And with parentheses, students were taught and different use. They have learned to misuse the parentheses. That is why very often students just leave out parentheses. What happened to the parentheses? Oh, I just didn't write anymore. This is another important thing that I'll try to explain that. I think I talked about this. Thank you. If students learn through understanding, then it becomes a knowledge, which means that it is lifelong knowledge of mathematics. It is not just to memorize something, which is they memorizing for the final test, and that's it. And then next day they forget everything. And of course, if it becomes knowledge, it becomes a useful tool in their lives and careers. Thank you.
So we now go to the question and answer portion. Who wants to? Okay, you presented.
Can I ask you a question about parentheses?
Yes.
I teach in Australia, and I'm familiar with the way they teach a lot in Southeast Asia as well. They often use parentheses a lot more to demark where an answer might be, or to make something clearer, rather than say I'm doing this first. Do you see that as a problem?
Yes. Because students have learned that they can have parentheses, if they write, for example, multiplication, they will write 5 and then 3 inside parentheses instead of writing 5 and multiplication 3. So, because they know this, did I understand your question correctly? Or?
Yeah, you're right. They probably put parentheses and put 5 times 3 inside it. If you've got an equal sign beside it, because it makes it easier to read. I've started doing it myself. But is
that's
it
exactly one good example of what I was trying to explain. Yeah, exactly.
Okay.
You said that mathematics is useful for the students in life. What do you mean by life? Do you mean some mathematical career or ordinary life?
I meant I had life and career, so for life I meant just life, everyday life. The way, because in life, even in relationship with people, you need brains in everything. That's what I meant.
What you need is reasoning skill, not mathematics.
Well, the mathematics.
Or integration or sequence.
Okay, let me give another example. Credit cards. It's very good tool of getting people in trouble, because it's very easy. You swipe the card, you take the goodies home, you are happy. But when it comes to pay, you are in trouble if you don't have money. And this mathematics can say how much money I have to use in a day, in a month, for example, how much I make. They have to do these calculations. I agree, analytical thinking is important, but this mathematical
But in
skill
that case,
also.
that's elementary school mathematics, not the college mathematics.
Well, why not? You are in a hurry and you have to walk. You think how to walk to get to the place faster. Or we can come up with really good, well, maybe not very high mathematics,
Well,
not like.
he doesn't buy mice or rabbits or horses.
Well, yeah, but people are not wise. They don't have that capability.
I think that's an interesting discussion going on in there. But you can also, of course, we've had 5 speakers. So you can ask questions for the other speakers as well. But I also let Anne first and then maybe.
Could we be more specific regarding developing analytical thinking? In your presentation, I got the following: that there is a book that you referred to, it's a book that was written by one of the teachers which you referred to. Could you specify other something which is in this book, just to outline the major step, or maybe what comes from your personal experience? But tell us, please, 1, 2, 3, 4, 5, what you believe would be important or critical to develop.
What comes to my Ananya Shiragatsi's book and Ananya Shiragatsi's methodology, where I discuss it in my book, is that Ananya Shiragatsi has a very systematic way of teaching arithmetic. While in comparison with some textbooks that I have reviewed for elementary school, there's no connection between calculation, counting 1, 2, 3, 4, and that 2 is 1 plus 1, 3 is 2 plus 1, so that counting is the same as adding 1. This is very simple knowledge to us, but if the kid was not taught that, but was taught to arithmetic, just saying 3 plus 5 is what? 8. So kid starts memorizing that. And then 5 plus 3 is 8, and there's no explanation of explaining, telling that, look, addition is something that you just put together. It doesn't matter which one you put. You put 5 first, then 3, or you put 3, then 5. So these small things doesn't teach the kids what is the value of the number. They don't understand that 8 is made of 3 and 5. It doesn't matter which way you put, or counting is adding 1, so you keep adding 1 to count. These are simple nouns, but this develop thinking about understanding of numbers much better than if they just were 3 plus 5 is 8, 4 plus 7 is 11. They just memorize it. Versus teaching this develops thinking about numbers.
Sir, before you shoot your question, is it
I have a question for Bella and also for Sophie.
Okay,
This is about, this for both of them. This is about the use of calculators, to teach calculus, and also
We do not use calculator.
I object, but you know what? I was asking regarding, a set of steps. You just referred to something that it is important to understand how, some arithmetic is done. I understand it's important. Is it all that you would like to come up with, or there is something else in order to develop analytical thing? If there is something else, please tell us, because that's what I didn't get from the presentation.
Can we have a short answer?
I missed it.
And then we'll go back to the question.
The shortest answer will be if teaching is being done through reasoning of every step, then students understand. First of all, they understand and they make a habit to reason every step. And the second is that they constantly reason every step, which means the brain works constantly and which develops analytical thinking. They analyze everything. It becomes a habit and it becomes a skill.
So maybe we can follow that up later after the session. Sir, wait. So maybe we can ask Sophie to answer your question first, and then.
Yes, she already
because
answered
it's
the
directed
question.
to.
No, she answered the question.
She has.
Yes.
I did.
I said
Okay,
there
sorry.
will
Yeah.
Okay.
Okay. Then.
Okay, my question to you is this, okay, do the calculators help us do it at the elementary level?
Did what?
Do the calculators help us do the students at the elementary level?
No, they don't. They are in fact bad. And elementary level students have to learn doing calculations on paper or methods that I explained, because this way they understand what is number, what is what, how much is what.
Then yes, I saw her hand first, and then I'd like to see another hand after
I'm
her.
interested in mathematics from the social sciences, and I was fascinated by your talk, where the students have to incorporate emotional intelligence with logical thinking, going out, and perhaps also teaching some mathematics through the questions they ask. But my question is, when you go out to the communities, the jails, and the veterans, what kind of questions do you ask actually? And I know that there are variables, but what would be the covariables? I think it's fascinating because it's a lot more difficult to teach that way than for the